Good morning, students. In our few sessions, we learned about different memory management techniques. In this section, we'll continue with our discussion on memory management technique. In today's class, we'll be learning about another important memory management technique called demand paged memory management. In our last class, we learned about what is virtual memory. A virtual memory is not a real memory, it's an illusion of large physical memory. Sometimes the available physical memory is less, whereas the job address space or the size of the job is more. So that amount of memory is not available. In the spite of that one, the operating system creates an illusion of such a huge memory so that even the larger program can be executed without any problem. Such an illusion memory, we call it a virtual memory. Virtual memory can be created in two different techniques. One is demand paged memory management. The other one is segmented memory management. In our last class, we learned the basic concept, very fundamental concept of demand paging memory management. In today's class, we'll be learning about the demand paged memory management in detail and its advantages and disadvantages. At the end of today's session, you will be in a position to understand how virtual memory can be implemented using demand paged memory management technique and the benefits and drawbacks of demand paging memory management technique in detail. In demand paging, what happens is whenever a job has to be executed, just similar to paging memory management technique, here also the user's job address space is divided into pieces of equal size called batch. The physical memory is divided into pieces of same size called block. And using suitable hardware mechanism, a particular page is loaded into particular block. So which page is there in which block will come to know through using a table called page map table. But the difference between paged technique and a demand paged technique is in paging, all the pages of a job must be there in your physical memory at a time. So before execution, suppose the job has 4 pages, then before executing the job, all the 4 pages of the job must be there in your memory. So unless and until one page is also not loaded, you cannot execute a job. But in demand paging, it's not like that. The processor start executing the first page. If the first page is in main memory, it will execute. After that, it will look for or search for the second page by looking at the page map table. If the second page is also there in the memory, means execute. Then it continues to execute the third page. Suppose the third page is not there in the physical memory main, then the processor sends a warning or a demand to the operating system indicating that the concerned page is not there in the physical memory. I cannot find that particular page in the physical memory. So that demand is sent by the processor to the operating system. Only after getting the demand from the operating system, then the operating system loads the corresponding pages into the physical memory. The space is not there in the physical memory means one of the page which has been already there in the memory or which is already its execution is over, that page is removed, is transferred to the second memory, and in that place a new page is brought. That means instead of loading all the pages at a time, as in the case of paging memory management technique, in case of demand paging memory management technique, the pages are not loaded all at once. They are loaded on demand only after getting the demand. So the pages are loaded on demand from the processor instead of loading them together. For this purpose, we need to modify the page map table of the paging technique. In demand paging technique, to decide which page to be kept in the memory, page map table are modified. So in the case of paging memory management technique, the page map table has only two columns. The first column indicate the page number and the second column indicate the concerned page or the corresponding page is loaded in or mapped into which block. So which page is available in which block, we will come to know that one in page map table in case of paging memory management technique. But in case of demand managed memory management technique, the page map table is provided with another column that indicate the status of the page. The status is only either yes or no. Yes means the corresponding page is in the physical memory. No means the corresponding page is right now it's not there in the physical memory. So during execution, whenever the processor see a page whose status is no means at that time the processor sends a demand to the operating system. Then the operating system loads the corresponding page by bringing it from the secondary memory to the primary memory. So in demand paging technique, to decide which page to keep in the memory, page map tables are modified to include another entry called status. It has only two values, y or n. Y means it is available in the physical memory. No means it is not there in the physical memory. So during execution, if the processor come across an entry in the page map table with a status equal to n means at that time it sends a interruption demand. The operating system must process this interrupt by loading the required page and adjusting the page map table entry correspondingly. Suppose the processor wants to execute a particular page mean that page must be in physical memory. Then in that case, to know whether it is in the physical memory or not, the processor first looks for the page map table. The status is y means it is definitely available in the physical memory, it will execute. And if the status is no mean, it cannot find that particular page in the physical memory. At that time, it sends a interrupt or a warning or a demand to the operating system to load the page. Then the operating system check whether space is there in the physical memory to load that page. The space is not there. If the page has all the blocks has been already used. In that case, one of the page is removed from the physical memory and transferred to the secondary memory and make space for the new page and bring the new page into the physical memory. Once a page is brought into the physical memory, its status, which was earlier n, must be changed into yes. So in a page map table, status n means not available in the physical memory. Yes means it is there in the physical memory. So only those pages for which the status is y, you can execute because they are available in the physical memory. For any page, if the status is no means, right now it is not available in the physical memory. It should be brought into the physical memory before execution. Since the requested pages are loaded into the memory on demand from the operating system or after demand from the processor, this technique is known as demand paging. So initially, a copy of the entire job address space is right now is kept in the secondary memory, and whenever a page is needed in the physical memory, then it is brought from the secondary memory to primary memory. Initially, all the pages are there in the secondary memory. During execution, if the processor want to execute means, then it needs the page 1, then followed by page 2, then the page 3, etc. Then one by one, it is brought from the secondary memory to the primary memory. Since they are brought one by one only after getting the demand from the processor, it's called as demand paging. So whenever a page is to be brought into the physical memory, then the page which is already there in the physical memory must be swapped because there is no space for the new page. The page to be replaced. So I want to suppose the operating system wants to bring one page into the physical memory at the time if there is no space. In that case, one of the page which was already there in the physical memory should be transferred to secondary memory. Then which page should be moved to secondary memory? That is decided by page replacement algorithm. Because one page from the physical memory should be shifted to primary. Sorry, one page in the physical memory should be shifted to secondary memory. Then a new page should be brought there. Then which page should be shifted to the second memory is decided by one of the page replacement algorithm. There are three important page replacement algorithm. FIFO, first in, first out. Next one is LRU, least recently used. And the third one is optimal page replacement. Anyway, I'm going to explain all these three page replacement algorithm in detail in my next class. So using any one of these techniques, a new page is replaced with the page which is there in the physical memory. It will be transferred to secondary memory. Then a new page is brought into that particular place. So this is how the page map table and the mapping is done in case of demand paged memory management. The first box which indicates here. So this is the job address page of job 1. The job one is divided into two pages labeled as page 1 and page 2. The next block indicate the address space of job 2. The job 2 is divided into 3 pages. Similarly, job 3 is divided into 1 page and job 4 has 4 pages. Then this box indicate the page map table for job 1. The page map table for job 1, how many pages are there? 2 pages. It is telling that the first page is in the 4th block. That means this page is kept in the 4th block. Then second page is available in the 6th block. You can see the status for these 2 pages. The status is Y, means they are available in the physical memory. Then it go to the page map table of the second job. There it is telling that the status for all the 3 pages is Y. The first page is available in the 3rd block. Next page is available in the 7th block. And the 3rd page is available in the 8th block, is loaded in the 8th block. Then for 3rd job, it has only 1 page. It is available in the 1st block. Next, for job 4, the first page is loaded into 2nd block because it is free now. Next page is loaded in the 5th block because that is also free. Now what happens is all the blocks have been used by the previous job. Now, in order to continue executing the 4th job, 3rd page should be brought into the memory because its status is no, means right now there is no place in the physical memory. In that case, a swapping is done. One of the page of either job 1 or job 2 or job 3 should be transferred to the secondary memory, and whenever that page is shifted to the secondary memory, that block becomes free. At that time, the 3rd page of 4th job can be loaded there. So this is how the mapping is done in case of demand paging memory management. As long as the status is Y, mean no need to swap because it is available in the physical memory. Only whenever the status is no, you can see the status is no for the last two pages of the first job, because right now all the places have been occupied. In any memory management, there are 4 functions. One is keeping track of status of each location, then allocation policy, allocation, deallocation. In case of these 4 functions are handled in a demand page memory management technique in using these 4 tables. So the first function, keeping track of status of each. This is done through 3 different tables. Page map table. For every job, there is one separate page map table. Memory block table. For one system, there is one memory block table. File map table. Again, for every job, one separate file map table. Only memory block table will be there for one for the entire system. Whereas for each job, there is separate page map table is maintained. And the policy of who gets the memory, all these things are decided by the job scheduler. A demand-based memory management provides you so many advantages. One is it's a virtual memory management technique. Even though available physical memory is less, still a program of sufficiently large size can be executed. In the previous example, we can see now you cannot load the third page and the 4th page of the job 4 because all the pages have been executed. Now altogether we require how many blocks? For the first job, 2 blocks. For the next job, 3 blocks. 3 plus 2, 5. Next one, 1 job, 6. And next one, 4. Altogether we need 10 blocks. But you have only 8 blocks. In that case, by having a space of 8 blocks in the physical memory, successfully the operating system executes a program of which needs altogether 10 blocks here. So this is the concept of virtual memory. High degree of multi-programming, more than one program can be there in the memory at any moment. It results in better utilization of both memory and the processor. But at the same time, it has certain drawbacks. One is higher cost, because in case of demand paged memory management technique, we need to maintain several tables that itself take some space. Page map table, memory block table, file table, etc. And swapping from secondary memory to primary memory and main memory to secondary memory during page fault, during the demand, it takes more time. So based on today's class, these are some of the probable examination questions. Explain demand paging memory management technique in detail. What are the advantages, merits and demerits of demand paging memory management technique? Write a note on different tables using demand paging technique. Let us revise what we have studied through some simple multiple choice question. In demand paging technique, pages are loaded into the memory all at once, one at a time, only after getting demand from the processor. None of these. The correct answer is C. Because the pages are not loaded simultaneously. The pages are not loaded unnecessary. Page map table is used for each job address pair, one table for the system, one for the operating system, none of this. Because for every job, we need to maintain a separate page map table that indicate of that particular job, which page is loaded into which block of the memory. The correct answer is A. Dash occurs. The page is not available in the main memory. So during execution, the processor looks for the page in the physical memory. If it is in that case, its status is Y. The page is not available in the physical memory, means it sends an interrupt. That interrupt we call it a page fault. The correct answer is A. In demand paging technique, PMT has additional entry indicating page status, system status, operating system status, memory status. It indicates page status, whether the page is there in the memory or not. FIFO is a page map table, memory block table, free status table, and page replacement algorithm. So one example for page replacement algorithm. The correct answer is D. So in a previous class, we learned the basic concept of virtual memory management. In today's class, we learned how the virtual memory management or virtual memory is introduced or created in case of demand paged memory management. The basic difference between paging and demand paging is in paging, all the pages must be there in the memory before execution. Whereas in case of demand, only the page which needs to be executed, that should be brought into the memory. Otherwise, that page can be in secondary memory only. So only they are loaded into the memory on demand from the processor. That's the reason why the technique is named as demand paged memory management technique. Unnecessarily, don't keep any job, any page in the physical memory. Only it is necessary, you bring it to the secondary primary memory. Otherwise, let the pages can be in secondary memory only. With this, I will conclude today's class. Thank you.